All right, so I guess we're going to use arc instead of vec. I'm not really sure what's happening here, but this feels wrong. I don't know. Let's
Hey,
find out.
YouTube.
Hey, have you ever considered subscribing to Logan Smith? Maybe you should give him a subscribe. Then hit him with that thumbs up. Pound him to thumbs up, boys. I just said that as an intro to one of my YouTube videos. I'm getting canceled. I'm literally getting canceled today.
We'll talk about why you might consider using arc slice t instead of vec t as a reasonable default in your Rust code.
Okay.
Now, this is
just saying right now, I'm having a very hard time understanding what's happening. I mean, I understand all the underlying principles. I just don't know why I'd want this over this. But okay, I'm just going to guess. I'm guessing up front. It's because arc, you can point to some sort of region. So you have this beautiful thing right here, right? It's beautiful. It's wonderful. Okay, you just follow a pointer to a region, which I don't see how it's any different than following a pointer to a different region. That's what I'm confused about. Is like, isn't it still the same amount? Okay, I'm curious.
A little bit of a hot take.
I'm missing some sort of indirect pointer somewhere, I bet you. Whatever vec of t is doing, I'm missing something, right? I'm missing something, and now I'm just stupid. That's what's it
so
has to be that.
Let me qualify it just a bit. So arc slice t can be a really good choice over vec t for immutable data. So if you build up a big sequence of data that you then never modify again after that, you might consider arc slice t. It's really good for data that you're going to be storing in structs or arrays or collections or just generally passing around. I'm not talking about a vec that you collect real quick as a local variable in a function or just that you use for some quick scratch space. Something that you're going to be storing for a longer period of time, you might consider using arc slice.
I have to know the reasoning. Because when you pass around an arc, you got to like clone that. And cloning is an atomic operation. That has to be more expensive than anything else you're doing. I'm just so curious. I must be missing something. I know I'm missing something, but I just wanted to pause it for a second. Can we all agree this animation is just very sexy?
T. And especially for data that implements clone. Now, this shouldn't be a huge surprise because clone is kind of the superpower of Arc, which we'll talk about shortly here.
It's also the superpower of untalented Rust developers. Am I right? Am I right? Just absolutely untalented Rust developers. I also use clone. Just throwing it out there. I'm untalented, just in case you're wondering.
But if you're going to be cloning big immutable sequences of data around all the time, Arc can really, really speed that up over vec t.
Oh, I think I understand
if you don't need clone,
now.
You can do even better than arc slice t. You can use box, but we'll talk about that at the very end.
Box me daddy.
So why am I recommending this? Well, there's three really big reasons. The first one we already touched on. So Arc has an extremely cheap constant time clone. So
it's true, but it still can be expensive.
No matter how big your sequence is that you're pointing to, it's going to take the same amount of time to clone it, and it's just going to involve incrementing an integer and memcopying the arc pointer itself, which is very, very fast, and it doesn't involve any memory allocations, which
But to be fair, it's an atomic increment, and when you drop an atomic pointer to it, you're also doing an atomic decrement. Am I right on that? So technically, everywhere there's an implicit drop, you're also doing an atomic operation, and everywhere that you call clone, you're doing an atomic operation. Well, I mean, I guess it's just like what's the trade-off? What's the trade-off you're trying to make? Like, do you want a bunch of atomic copies and drops, like increments and decrements in like very hot path code? Probably not. Atomics are pretty cheap. They are cheap. In some sense, there's still, what is it, like hundreds of instructions compared to copying a whole vector? Yeah, I would agree with that, compared to copying a whole vector, but let's see what happens.
Normally
let him cook.
A vector.
Sorry, I'm not letting him cook. I see him put one little ingredient in the dish, and I'm already just like, what the hell's this meal? Ain't nobody just eating onions. Okay, sorry. Sorry.
So this is a huge optimization that you can get very, very easily just by switching over to arc slice t. Another reason is that arc slice t is only 16 bytes. It only needs to store a pointer and a length, unlike a vec, which needs to store a pointer, a length, and a capacity.
We call that a girthy pointer, okay? Some people tried to call it a fat pointer, but we all know they call them a girthy pointer, okay? The real ones know. It's always been a girthy pointer. We've all wanted a nice girthy pointer in our language, and now we have access to one.
Making it 24 bytes. Now, that's only an 8-byte difference. It's not huge, but if you're storing lots of these things, especially in a struct or in an array, that extra memory can add up, and it can decrease your cache locality, and it can make it harder to walk a big series of these things. And then lastly, the third reason is that arc slice T implements deref slice T just like Vec does. So you can do all of the same read-only stuff on your arc slice T that you can on your Vec T. You can ask for its length, you can iterate over it, you can index into it. And this is really important because these first two bullet points are cool, but I wouldn't necessarily go out of my way to recommend them if arc slice T was way more difficult to use than Vec is, but it's not because it implements deref slice T. It also implements a bunch of other traits that you're probably going to want. And it makes it so that arc slice T is really just a drop-in replacement for Vec T in many, many circumstances.
It does feel very, very nice in the sense that if you've ever used any sort of arcing, like right, you have to arc a semaphore. Also, it just feels good. Just feels good. Why not RC? That's what I want to know. Why not RC? I'm very curious about that because arc means you can pass it between threads. But if you don't need to pass it between threads, why arc? Why not RC? Is RC analogous to using arc in this specific case? There must be a reason why arc over RC or no mention. He says you should use RC if you can, or even box. Okay, so spoiler alert at the end.
So these first two bullet points are nice performance gains. This third one means it's basically not any harder to use arc slice T than it is Vec T, so you might as well just reach for it first. So I've been talking about arc slice T versus Vec. I'm actually going to spend the rest of the video talking about arc stir versus string, which is the exact same dichotomy. It's just a little bit easier to talk about and a little bit easier to think of examples of. But everything that I'm going to say about arc stir versus string is going to apply directly to arc slice T versus Vec. Now, I also want to mention that anytime you're using arc, you should always try and use RC first if you don't need the thread safety that arc gives you.
How do lifetimes work with this? How does that work? If you have because obviously there's some underlying string that has to exist, and then you have this, but you don't have let the man cook. I know. I'm just curious. Okay, they call me Betsy Quirius. Okay, I just have a couple questions here. By the way, reference. If anyone gets the reference, I'll be incredibly impressed. But I'm just curious. How does lifetimes and all that get figured out with this?
I'm just saying arc here because it's the most general version of the advice.
You don't allocate a stir. A stir is just a reference to a string. You always have to you always have to have you gotta have a lifetime associated in some sense with these little stirs. So I'm just curious, how does an arc work with the string? I know, let the man cook. Shut up.
But if you can get away with RC, you should definitely try because it has lower overhead than arc. Now I also want to clarify.
Okay, good. He did say RC. Okay, great. Okay, I'm on Team RC. Team RC, people.
Something else. I want to point out that I'm talking about arc stir, not arc string. Arc string actually has some of the same upsides as arc stir, but it also has the very significant downside that you need a double pointer indirection in order to actually get to the data that you care about, which is your character data. I'll show a visualization of this at the end, but arc string is just generally kind of clunky and memory inefficient. And
do you understand why? String is like a vector, right? So you have to follow the vector is a big old girthy pointer, and so you're just having a girth pointer to a stir. And so if you have a pointer to a pointer, you don't really want to do that. You don't want to do a pointer to a pointer, right? This is just a pointer to the thing, right? So it's less girth. It's not the girth. My JS brain doesn't understand double pointer indirection. Yeah, too much girth. You want less girth.
That double indirection is going to be really bad for performance. So I do not recommend using that. I'm talking about arc stir. The power of Rust's wide pointers is that we can point an arc.
You just call them wide pointers? Okay, I've never heard the term wide pointer. I'm not going to lie to you. I've never heard the term wide pointer. I've heard fat pointer and clearly girthy pointer. But wide pointer, that's a whole new one for me. I've never heard wide pointer. Quit wide shaming. I'm just saying, it's a wide pointer. Thick pointer. Ooh, I want that thick pointer.
Arc directly at a dynamically sized character buffer out on the heap. So let's say that I'm working on a game, and I have a type in my system called monster ID. And under the hood, it's just going to be represented as some text. And I want to use the string type to manage that text for me.
Okay.
So the first thing that I might want to do on my monster ID struct is derive a bunch of traits. I want to be able to clone this thing around.
Classic Rust.
I want to be able to print the debug representation, compare it, hash it. I also want to use Serde to do some serialization and deserialization. maybe from a configuration file or just from some save data. So I want to slap all those derives on my monster ID struct, and I want it all to work. And that will work with string. Next, I want to have a method on my monster ID struct that just grabs the underlying representation as a string slice. Maybe I want to log this out to the console. Maybe I want to use this for analytics somewhere. So I just want to access the underlying data as a string slice. And that's pretty easy to do with string. Next, I want to have some configuration data somewhere. And this is going to be a hash map of monster ID to their stats, you
got to clone it out, though,
and all that stuff. And it's going to be keyed on monster ID, which is why I needed to derive eek and hash. And this all works just fine with a string as an underlying data type.
Did you just say eek? Logan Smith, you have mellifluous tones and a grasp on pronunciations and terminology I just do not have. I have never once called it eek. I've always just called it equal. I never once even thought about just calling it eek, which is, I mean, I can see why we've arrived at this conclusion, and maybe I feel a little stupid thinking about the fact that I've never done it yet. I'm just saying, it's just something that's never really landed in my head. If he does say mutt, I am going to just rage quit this video. I'm just going to shut this video clean off. Clean off, okay? I'll go, oh, yeah, before you go, oh, well, you call char char and not car. Obviously, character, char. Oh, you done up with your little pronunciation there, tough guy. Hey, guess what, okay? This is my world. I get to choose my own inconsistencies, okay? I don't like mutt, hands down. Hands down, don't like it, don't want to like it, not going to like it.
Next, I want to store these things in a big list of all of the enemies that I've ever spawned.
Okay.
Notice that I'm using Vec here because this is going to be something I'm going to be appending to as the game runs, and I'm probably going to be cloning monster IDs into here. And this list could get fairly large, and it's going to be a bunch of these monster IDs sitting right in a row.
Okay.
Next, nice. I need some kind of functionality for creating an actual enemy that I'm going to use in my game based on a monster ID. So I'm probably going to be cloning monster IDs into this function, maybe cloning monster IDs into the enemy instance so that each enemy instance knows which monster it is. And lastly, let's just say I'm storing some stats in a B-tree map that's my monster ID to the number of times I've destroyed that monster throughout my gameplay session. And I'm just using B-tree map here as a different type of...
That poor monster just keeps getting destroyed over and over again. You're telling me he has to get destroyed repetitively? What kind of weird ring of hell is this game that he's designed? At least give a fresh new life a chance and opportunity to run around. Just destroying the same one over and again. This is painful.
Data structure than hash map, and we can use monster ID as a key in a B-tree map because it implements ORD. So here's a handful of different use cases. There's probably more. This is just an example of how a basic type like this can start to proliferate throughout your entire system, and you can start needing to clone it around all the time.
Yep.
You can start needing to store it in all these different data structures, and suddenly the cost of those operations starts to matter and starts to add up. So let's look at the cost of cloning this around.
I do want to take a moment here. This is, this is the whole argument of pessimized code. Often you find that things are just kind of slower and clunky, but you can't point to any one problem. And it's one of the hardest parts, especially when navigating through JavaScript libraries and JavaScript applications, is that they can feel slow, they can use a lot of memory, but it's not like there's just one spot that's look at this. This is the one spot in which you use all the memory, right? No, it's just evenly happening all the time, everywhere. You know what I mean? It hurts.
And just the overall memory footprint of this when we use string. So here's how string is represented. So the actual string data in string is represented...
The goblin these nuts! Oh, got him!
...as a character buffer that's out on the heap. And string allocates enough memory for your text, obviously, but then also it allocates a little bit of extra space so that it can grow without needing to reallocate. So here we have goblin with 4 extra bytes of spare capacity.
These nuts?
In case the string needs to grow anymore. Although we know that it doesn't because goblin is already a monster. Next, the string struct itself is made up of 3 8-byte words, a pointer, a length, and a capacity. Now the pointer just points directly at the string data. The length refers to GOBLIN, so it's 6, and the capacity includes that...
I'm so stupid. I'm sorry. I don't know what's wrong with me, but I can't help it. If there's a possibility of a D's Nuts joke, I'm sorry. I just can't like leave that opportunity up to chance, okay? You can't just toss out a goblin without it, okay? I mean, come on. I mean, you even had 4 characters left. You could have been like, we could have penned to the string Deez. Oh my goodness. You could have hit him with the D's right there. Just meme on the kids, okay? You just meme on them. So good.
Extra 4 bytes at the end, so it's 10. So let's look at what it looks like to clone a string. So first we need to clone the entire character buffer. So first we need to allocate more memory, and then we need to copy over all the characters, which is a linear time operation. In other words, it takes longer the longer your string is. Then we need to create a new string struct on the stack and point it at the new character buffer. Notice that this time we shaved off the extra capacity because strings clone isn't going to over allocate. It's going to give you an exact
I didn't know
size
that.
buffer. So we just have this extra spare capacity of 6, which isn't really helpful to us right now because it's the same as the length.
Okay, I didn't know
And if
that.
we want to make another clone, we have to do the exact same thing. We need to allocate a new buffer, copy all the characters over once again, and then create a new string struct on the stack that points at it. And again, we have this extra capacity field here that's not really useful to us.
Yeah.
So hopefully you can see that this process of allocating new memory, which by the way is very expensive, is a little bit cumbersome, and the string structs are just kind of large and overly bulky just for the simple purpose of talking about goblins.
Just want to talk about goblin. These nuts. Okay. I think we see some of the issues here. I don't know how fast or slow allocating more memory is. Generally, it's considered slow, but it's it's usually the cache misses because you don't know where this is going to go. You can't really guarantee adjacency and all this kind of stuff. So I get that. I understand the general reasoning. I just got
So now let's look at the
here.
same situation,
Okay.
but using argstir instead of string.
I'm still curious
So
about
with
this
argstir,
referencing
we
problem.
start out with some heap data that looks different. So first we have these 2 8-byte words. One of them is a strong reference count. The next one is a weak reference count. And then we have our actual string data. So this already looks bigger and kind of strange, but don't worry, it gets better. So our arcs on the stack are just a pointer and a length. They're only 16 bytes because they don't have that extra capacity field that the strings had. So it's just pointing at our reference count out here. And let's look at what happens when we clone. So all we have to do is copy that struct that's on the stack and increment our.
How do you initialize an argstir? I guess I've never really played. I guess I've never really played with one of these. I don't know this whole strong and weak business. Because if they're strong and weak already within the stir, why do I need lifetimes? Unless I get the reference to the stir. I guess I don't have any idea what a stir is. Now that I think about it, I've never looked at the underlying representation of a stir because I've only ever used it as a reference. Oh, that's the arc. Okay. That makes way more sense. I was having some emotional difficulty getting over this because I was wondering, why do we have weak and strong references? Doesn't this add like a whole runtime to dropping stirs? But this, okay, this makes more sense.
Reference count. So now it's 2. You notice we didn't do any kind of.
Stir is a verb. Arc is a noun. Don't come in here with English. Okay, you already know English is like my second language, right? But I got a question for you. Are you a strong goblin or do you weak goblin? Just saying. You weak goblin on these?
kind of memory allocation. We didn't do a deep copy of our string data. We're just referring to the same string data in 2 places now. So we can very, very cheaply make clones of this. And the fact that this string data is shared between multiple arcs also increases the chance that it's going to be in cache when we look it up, because it gets loaded into cache anytime I use any of these 4 arcs to read from it versus the.
Does that mean that this pointer to read the thing out of an arc, it technically does a pointer plus? Is that correct? It does a pointer plus 2 U sizes to read whatever data? Is that what deref does? I assume deref just goes pointer plus size of U size times 2. Probably makes that a constant, so you don't have to like do a multiplication every single time you want to deref something, and then throws it in there. Probably is my assumption.
Strings where the memory that they're pointing to would only be in cache if I had already looked it up recently using that specific string.
Okay.
So you can see that this whole thing is just much lighter weight. These arcs themselves are smaller, so more of them can fit in the same amount of memory. And frankly, this is just a much smarter use of resources for our immutable string that we're passing around through our program.
Fair.
Also, these 2 extra words that we're paying for on the heap are divided among...
Can we just take a second here and say that monster ID was a bit confusing here? Just a nit. Let's do a little nit here. Monster type might have been a better term here, because I'm over here thinking you got like some UUIDs or some shit out there, and I wasn't understanding what was happening. I was confused.
every single arc that we have. So they're kind of amortized.
By the way, don't
whereas we had to pay for an extra word for every string that we used on the stack. These 2 extra words that are on the heap, 2 is more than 1, but they're shared among every arc instance.
You said the same thing.
So it's much less at the end of the day than that
go.
extra word that each and every string had to carry along with it.
Okay, this is good though. This is
so
a great
let's see what it looks
why.
like and feels like if we just plug arcstir directly into our monster ID instead of string. So first of all of
I literally don't know how to initialize a stir.
Work exactly how they did. You can clone an arcstir, you can debug print an arcstir, you can compare it, you can hash it.
Yeah.
You can also serialize and deserialize it, although you do need to activate a serde feature in order to do that. Just because
who's going to be the first person to write a macro to create a derived macro so I have to quit doing this? Who's going to do that? Who's going to do that for me? I want my own derived macro that derives the proper derivings that I just want. Give it to me all derive. I just am tired of typing all the things, right? I don't want to type it all. I don't want a macroception. I don't want that.
There's some minor small print that you want to read if you want to do that, but it's
derive all. I want all.
Do. So all of that still just works like it did. What about our asStir accessor? Stuff. This function does not need to change at all because arcstir implements deref stir just like string does.
I still don't know how to initialize an arcstir. Can somebody tell me how to initialize an arcstir? I have never stirred in my life. I know how to string, how to stir. No, you can't just say from stir. I don't know what that means. Okay, how did you get the stir? Okay, but that's a static reference. I don't want a static reference. I want a non-static reference. Does this only work when you have a compiled in string into your program? Because that's my whole thing is, how do I do a lifetime, right? That's the only way. Okay, see, that, no. Okay, that emotionally hurts me. Okay, can you do that? Can you do a from string for arcstir? I don't believe you. Hello world, no, see, that, no, that's cheating. This is cheating. That's not what I wanted. I don't think you can do this, T-Got. I really don't think you can do this. Because you need to be able to do a lifetime on this thing, and there's no way it can point to something like that. Right? Because asStir, I don't think so. Try it. You try it. I have to get a Rust program up. Do I even have a Rust program? Rusty Arduino, Rust TypeScript, Rust. Do I have anything with RS? Okay, there we go. Let's go like this. Oh my goodness. Let's go let foo equals string from hello world. All right, there we go. And then let's go foo arcfoo equals arc from, let's see, foo as stir. Now notice, here's the deal. It's not. It shouldn't work. It's not going to work, and it's simple because what comes out of as stir is not right, right? What comes out of asStir, see, you got this problem here, see? Because you got a reference. You got that thing. You got that thing's going all effed up. I don't know what to do here. I don't know what to do with this, but something's wrong. I know it's going to be more difficulty because asStir is a reference to a string. It's not the stir. Can I star that son of a bee? See, then it's just like, I don't know the size of this thing. What's the size? I don't know. What's the size? I don't know. So is it purely just because you're actually just going like this? Let foo equals, here, foo is a static string, hello. Can I just do this? Foo. What? Porque Maria? What do you mean, Porque Maria? Oh, I need one of those, huh? Can I, like, star it? How the hell do I get this thing? I don't know how to use one. Okay, arc stir equals foo into. Got it, first try. I knew I'm a genius. I knew it. I knew it. I knew it. I knew it. I was better than everybody here. I could just feel it. I could feel it. Can you shadow that thing, or does it drop it all funny? No, it doesn't. Nice. Look at that thing go. Look at it go. Look at it go. It's so good. Yeah, I'm pretty much a genius. Pretty much prodigy programmer here.
Can just take a reference to it and return.
I still don't know how to do it with the string, though. I don't think I can do it with the string. I actually don't think it's possible doing it with this. Right? Okay. First try. Genius, people. Genius. Okay, I truly actually don't understand how this works. Real talk. I don't understand how this works. Because how does the drop work? How does the drop work on stir? Does stir have a drop function that clears up the memory? I'd have to look into the into implementation to understand what's happening, but I don't think I can. Classic. Look at that. That feels good. Look at that implementation. Inline that shit. Why don't you inline that right now? Inline it. Just put it in. Just put that in. Arc does. Arc does.
And that turns into a reference to a string slice. So nothing about this function needs to change. It all works perfectly.
It's super interesting. I didn't realize this. Okay, you've convinced me. You've convinced me to never use string again and clone out RCs. Honestly. This is kind of wild. This is kind of wild that you can do this. I'm flabbergasted, okay? Flabbergasted.
Next, what about our hash map of monster ID to enemy stats? Well, our monster ID struct still implements eq and hash because arc_stir does.
There's that eq again. Okay, hey. I don't know if I like it. I'm not going to lie to you.
And so nothing needs to change here. And in fact, I would argue that this is way more appropriate to use arc_stir for this because string gives you a lot of APIs for modifying the underlying string, but you can't modify a hash map key because you might break the invariance of the data structure. So representing your key using an immutable type, like what arc_stir gives you, is much more appropriate than using string.
Okay, yeah.
Moving on.
Yeah.
My vec of monster IDs is going to be much more cache efficient now because I've shaved off an entire word from each and every monster ID and is 2/3 the size that it was before. My function for creating an enemy...
Is that true? I don't think that's true. It's not 2/3 the size that it was because you still have the string. I guess it's 2/3 the size for the pointer cost. 2/3 the size for the pointer costs, and that's that. Okay.
Instance out of a monster ID is probably more efficient now because I imagine this involves some kind of cloning of the monster ID, which is much more efficient now that we're using arc.
Yep.
And then lastly, our B-tree map is kind of the same
I wonder if that's true. I wonder, is there a size of string that's better to clone? I don't know. Is it always better? I don't know. Because arc is still, I mean, it's fast. It's like fast. But how fast?
The hash map, it's just more appropriate to using immutable data as our key type because you're not allowed to modify the keys in a B-tree map anyway. And this B-tree map is going to be more efficient now because it's storing data that's smaller and doesn't have to pay for the cost of being mutable when it doesn't make sense for it to be mutable.
It's not copying the data, correct. But it is incrementing an atomic integer. And so that costs something. Also, every single time you drop it, there's an inverse cost as well. I would assume dropping a string memory is less expensive than dropping a string memory with an atomic counter as well, right? I don't know. I'm just saying I don't know. This all seems to make sense in my head, right? But intuition about what is fast and what is fast, they're different. They're cats versus dogs, okay? This feels fast. It looks fast. On paper, it's fast. What happened? It's slow, right? It's just like using an array versus a set. A set, by all measures, just looking at it on paper, instant access to anything you want, feels faster. But is it faster? Well, it really depends. Really big depends going on there.
So Arcstar wins in all of these examples. It's more efficient, and it's a drop-in replacement. So why not just use it?
I'm curious if that's true, but
so
that's
a takeaway
very
here
exciting.
that I've kind of been hinting at, but I'm going to say explicitly, is that vec and string are for modifying buffers of stuff. They're for pushing and popping and extending and trying.
Are they? Are they? You'd have to have a mutable reference, though. They're not technically... There's nothing that says they are for or aren't. I mean, generally you set something up because you have an unknown shape, so they are mutated for some amount of time. But there's nothing that says that they're strictly for that. It's designed to be. It's designed to have the ability to. I don't know if its telos is to be mutated. Can we say that? Can we say that? I think one of its functions is mutability. But I'm not sure if its telos is mutability. Just throwing it out there.
Truncating, and if you don't need that stuff, don't use them because they have some extra cost that's associated with that. So all of the methods on vec and string that are super interesting, you notice that all of these methods take a mute self.
Yeah,
so they're all about modifying the buffer and mutating it and changing the shape of it. And
you can have a non-mutable string, though, right? Like we go back to this thing. This guy's not mutable, right? I can't mutate him. Now, obviously, I could turn him into something that's mutable, but right now, it's not mutable, right? Unless if I explicitly say it's mutable, it's not mutable. Just saying.
If you don't need any of these features, then don't use vec and string. If you just need to look at some data and say ask for its length to see if it's empty, index into it, iterate over it, split it, search in it.
Does Serday work with a JSON like this? I'm actually really curious. Does Serday work with a JSON for this? Because one could argue, if you copy a lot of JSON, would it be nice to swap out these things and use a different type of copy? Like, right? You could imagine a bunch of RC strs as opposed to strings. Is it better? I don't know. Serday is
all
malware.
All of that stuff is provided.
Did you not see their shipping binary? And then the guy Detolne didn't care about it, despite him actually making my life easier and hundreds of crates. And he's the single most prolific contributor to Rust altogether. He decided he wanted faster compile times and shipped down a binary. And that's when we all knew he was actually the Faustian bargain, handing us something that looks good, but at the end will be nothing but malware. You know, maybe not. You know, maybe he was just trying to make things faster. Okay? Maybe the guy was just trying to make life a little faster. He came up with the clever idea and got wrecked by the community. Is it terrible that he got wrecked by the community? I mean, I think that it was a bad idea, so I'm happy that he got checked. I think the more funny part is that 1 week ago, what sponsorware or whatever, that weird virus of software that went into mock the library for testing, they just got done shipping binaries, and everyone was like, whoa, this is C#. We don't like being spied on, okay? By the way, I sent this message from Visual Studio Code Enterprise Edition, right? And they're complaining about being spied on and all that, and it was very funny timing that 1 week later, after everyone losing their shit about a binary, someone else is like, hold my beer. We're going to do the same thing except to Rust, the most authoritarian language of all time. Everyone will be happy with this one. Kabam! So good.
Slice T, both of which you can get at very easily through an arc. And so you don't need the full power of string and vec if you just need to look at some data, and you can gain a lot of performance by not paying for string and vec if this is all you need. So that's why you might want to use arc slice T over vec or arc stir over string. Now, I do want to show off argstring because I mentioned that it was bad, and this is why. So argstring starts off the same way as string
Get
does,
outta
with
here.
a buffer with some spare capacity. But then we also need to put
Yeah, this makes
a
sense.
string itself into an arc. So you see we have those extra 2 words at the front for the reference count, and then the string stuff after that. And then
And
the arc
this.
is going to be pointing at that string, and cloning it is going to, it's going to clone the reference to the string.
Which is
But
nice.
you see that if we wanted to get at the actual text that says
Ba-da-bop,
goblin,
ba-da-bop.
we would have to jump
These nuts.
to the string and then jump from the string to the goblin. And this whole
These nuts.
thing is just kind of cumbersome and awkward. And this is why argstring is not a good idea when we can do much better
Got
with
him so many
argstir.
times. I got him so
Lastly,
many
I
times.
mentioned that if you do not need to clone, you can do even better than arc by using box stir. And this is essentially as good as you can possibly get, assuming you don't need to clone. So this does not have any extra spare capacity. This just allocates something up.
But by the way, I know he mentioned it in such brief passing. He really should have mentioned a bit more about why use RC over arc. Like if you don't have threads to send something to, what's in the box?
What's in the pockets? What's in your pockets? What's in the hobbit's pockets?
Real talk. It feels like the whole thing should have been an RC and then just assumed to be an arc if you need to send it between threads. I'm just saying,
From the heap, points to it, and knows how big it is.
right?
So you cannot do any better than this. But when you clone, you are doing a deep clone of that heap data. So that's going to be a memory allocation and a linear time copy. But if you're not supporting clone, you can't do any better than this in terms of memory efficiency. So consider box stir if that's your use case. So that's all I got. That's
Okay.
going to do it for this one. Let me know what you think. Thanks for listening, and I'll see you next time.
That was great. Logan, that was great. That was really, 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 really interesting. I'm actually a little bit shocked that that this, I guess, wasn't more talked about earlier on and kind of some of the things. I know they kind of talk about these things, but I've never put them all together. Very, very interesting stuff. I really like that. Logan, you make an amazing video. I think anyone that's watching it, go subscribe to the guy. Fantastic, high quality. The name is the Goblin D's Nutsogen.